Alright kiddos, welcome back. Hey, are you excited to balance some more redox equations? I know I am. They're actually sort of kind of fun to do. So we have a couple on this example we need to wrap up, and then I have a couple more that I've done for you on another page, just so we can get some more practice. You really start feeling comfortable with these after you've done about a dozen or more, and we are not close to that yet. So here we go with letter F. Let me do it for you, and I'll let you try letter G on your own. Letter G is actually a bit tricky, but I'll let you play with it to see what you end up with. So if you remember, the first thing we do is we assign oxidation numbers to each atom in the equation. So in the dichromate ion, the oxygen's -2. That gives me 14 negatives because there are 7 oxygens there, folks. I have to have 2 negatives left over. I have 2 chromiums to get me to 12 positives, so that would be 6 positive for each chromium. I is -1. You can see it's the iodide ion, so that's -1. Chromium is 3 plus here. It's the chromium ion. And I2 is the elemental iodine, so its oxidation number is 0. So step 1's done. Step 2, let's balance the atoms who changed oxidation numbers. Chromium went from 6 plus to 3 plus. There's 2 chromiums on the left, only 1 on the right, so I need to put a 2 there. And I went from -1 to 0. It changed oxidation numbers. There's 2 iodines on the right, so I need to put a 2 in front of the I negative on the left. Step 3, balance electrons gained with lost. So it looks like chromium goes from 6 plus to 3 plus. So each one gains 3. But aren't there 2 chromiums that do that? Right? So if each one of them gains 3, and there are 2 chromiums that do that, isn't that a total of 6 gained? Iodine goes from -1 to 0. Each one loses an electron, but there are 2 iodines that do that, so we have 2 that are lost. So let's go ahead and triple the number of iodine-containing species. Put a 3 in front of I2, and let's erase this 2 in front of I negative and triple it, make that a 6. So now we have 6 electrons lost with 6 electrons gained. Next up, balance the ionic charge. So dichromate is 2 negative, and the iodide ion's -1, and there are 6 of those for a total of 6 negatives for the iodides. So that's 8 negatives on the left-hand side. On the right-hand side, I have 2 chromium 3 pluses for 6 positive, and I2 is neutral. Boy, that does not balance. This is an acidic solution, so I will use H pluses to balance it, and I'm going to have to add 14 H pluses to the left side. That way I'll have 6 positives on each side. So I have to actually write in my equation 14 H pluses as part of the reaction. And then the last step is to balance all hydrogens using water. Well, I've got those 14 that I just wrote in, so I need to put 7 H2Os on the right-hand side. Now, if we've done this correctly, the oxygens will balance. And let's see, I have 7 oxygens on the left, 7 on, yep, it balances, and there is a balanced redox reaction. All right, give letter G a crack. Letter G, there's something strange there, so I want to see how you handled it. So pause the video, let's see how you do, and give it a couple of minutes, try it for a couple of minutes, see how you do, come back, and then I'll do it for you. All right, welcome back. That was ugly, wasn't it? All right, here we go. Let's assign oxidation numbers. Aluminum's 0. It's in its elemental state. Here, oxygen's -2 and hydrogen's +1. No big deal there. In water, oxygen's -2, hydrogen's +1. H2 is elemental hydrogen, so its oxidation number is 0. And AlO2 negative, oxygen's 2 negative, and that aluminum becomes +3. All right, here is the problem, kiddos. There's 1 aluminum on both sides, but that aluminum goes from 0 to +3. Don't you agree that 3 electrons were lost? That part's pretty easy. But then we run into hydrogen. This hydrogen goes from +1 to 0, and this hydrogen goes from +1 to 0. So the question is, which one do we deal with? Well, if we go with this hydrogen, we go from positive 1 to 0. We lose an electron. We gain an electron to go to 0. And the same is true with the one in water. We would gain an electron to go with 0. Let's use water. Let's have water become oxidized, or reduced, excuse me, because I already have those balanced. There's 2 H's here and 2 there. So, if each hydrogen gains 1, wouldn't that be a total of 2 gained? Alrighty. So if 2 are gained and 3 are lost, let's go ahead and balance the electrons gained with lost. We'll triple the number of hydrogen-containing species by putting a 3 there and a 3 there, and we'll double the number of aluminum species by putting a 2 there and 2 there. Now let's balance the ionic charge. We have a -1 because of my hydroxide on the left-hand side, and 2 negatives because of the 2 AlO2 negatives on the right-hand side. Now it doesn't say whether it's acidic or basic, so we will assume it's acidic. So we will add a proton to the right-hand side to give me -1 on that side as well. So we'll write that in as plus H plus. So we have to add a proton over there. Now we'll balance all hydrogens using water. So let's see, I have 3 hydrogens, or 6 hydrogens here plus another one makes 7. I have 6 hydrogens here. Whoa, those balance. 7 hydrogens on both sides. Okay, good. And then if I did it correctly, all oxygens should balance. So I've got an oxygen here and 3 oxygens there for a total of 4. And 2 AlO2s, so I have 4 oxygens there. Yeah, they balance. So this equation, as weird as it looks, is a balanced redox equation. That was sort of a tough one. If you missed that one, don't lose any sleep over it. All right, let's do a couple more. I have 2 more set up for you here. Why don't you try the first reaction on your own. Pause the video, give it a whirl, and then come back. We'll see how you did. Okay? See you in just a sec. All right, welcome back. Let's assign everybody an oxidation number. So oxygen's 2 negative there. That gives me 6 negatives. That means the arsenic must be 3 positive. And the nitrate, oxygen's 2 negative. That makes that nitrogen 5 positive. H3ASO4, oxygen's 2 negative. Hydrogen can only be positive 1 there. So that gives me 5 positive for the arsenic. NO, oxygen's 2 negative and nitrogen's positive 2. Okay? All right, let's balance the atoms who changed oxidation number. Arsenic went from 3 plus to 5 plus. There are 2 on the left side and only 1 on the right. So let's put a 2 in front of that to give me 2 arsenics. And my nitrogen went from 5 plus to 2 plus. There's 1 of each. They balance. Next up, balance electrons gained with lost. So arsenic goes from 3 plus to 5 plus. Each arsenic lost 2. But there are 2 arsenics that do that. So if each one lost 2, and there are 2 arsenics, aren't there a total of 4 lost? Nitrogen went from 5 plus to 2 plus. It looks like it gained 3. So 3 were gained. What number do 4 and 3 have in common? 12, okay. So I want to quadruple the number of nitrogen species by putting a 4 there and a 4 there, and we'll triple the number of aluminum species by putting a 3 there, or arsenic species, excuse me, and we'll change that 2 to a 6. Alrighty. So now electrons gained and lost have now balanced. Next up, let's balance the ionic charge. As2O3 is neutral, but there are 4 nitrates. They are each -1, so there's 4 negatives on the left-hand side. And on the right-hand side, I don't have any ions, so the charge is 0. This is an acid solution, so I'll add 4 H pluses to the left. So I'll put 4 H pluses as part of the equation. And then finally, we'll balance all hydrogens using water. So I have 4 hydrogens on this side. I have 18 hydrogens on this side. I need 14 more hydrogens, don't I? So we're going to add water to this side, 7 waters. And that will give me my total of 18 hydrogens on both sides, so the hydrogens balance. Now, if we did it correctly, the oxygens should also balance. So let's see. We have 7 oxygens here, plus 9 oxygens there. So what are we up to? 7 and 9 is 16, plus 12 more is 28 oxygens. Wow! How many do we have on the product side? Well, we have 24 here, plus 4 more is 28. Yeah, that redox equation is balanced. That's another tough one. Now, look, you might be making mistakes. You might be getting frustrated. The important thing is, are you learning from your mistakes? Are you saying, oh, I see that now. Oh, I get it. If so, then you're making progress. Okay, don't get too discouraged. All right, let's try this last one. Pause the video, give it a whirl, come back and we'll see how you did, okay? All right, let's change colors. Let's see how you did. Did you assign chlorine an oxidation number of 0 there because it's in its elemental state? Oxygen's 2 negative. That makes each, let's see, we have 6 negatives. That makes each sulfur 2 positive, I believe. On the product side, Cl negative is already 1 negative. It's an ion. SO4 2 negative, the oxygen's 2 negative, and the sulfur's 6 positive. Next up, let's go ahead and balance the atoms that changed oxidation numbers. Chlorine goes from 0 to -1. There are 2 chlorines there, so I need to put a 2 in front of the Cl negative there. Sulfur goes from +2 to +6. There are 2 sulfurs there. I need to put a 2 in front of the sulfate on the other side. Okay, next up, let's balance electrons gained with lost. Chlorine goes from 0 to -1. Each chlorine gains an electron. 2 chlorines did that, so there are 2 gained. Sulfur goes from +2 to +6. Each sulfur lost 4 electrons. There are 2 sulfurs that do that, so there's a total of 8 lost. Okay, we'll need to quadruple the number of chlorine species, so I'll put a 4 in front of Cl2, and we'll change that 2 right there to an 8. We've got to quadruple that, kiddos. All right. Next up, let's balance the ionic charge. So Cl2 is neutral. Thiosulfate, S2O3, is 2 negative. On the product side, we have 8 Cl negatives and 2 SO4 2 negatives. So we have 12 negatives on the right side and 2 negatives on the left side. It's an acid solution, so it looks like we need to add 10 H pluses here to give me 2 negatives on both sides. So let's write in plus 10 H pluses. Last step, we'll balance all hydrogens using water. So we have 10 hydrogens on this side, so let's add 5 H2Os on this side to give me 10 hydrogens. Now if we did it right, all oxygens should balance. So we have 5 O's plus 3 more is 8, and we have 8 O's. Oh, I didn't add them up. So 5 O's here plus 3 more is 8. On this side we have 8 oxygens as well with my SO4 2 negative. So, whoops, those do balance. All right, you're sort of kind of getting this? All right, we'll try a few more in class, and we'll have several on an upcoming assignment. So good luck to you, kiddos. Keep your head up. See you soon. Bye-bye.